Right, so this is Matrix Live demo section. We run demos every month, and we want to share them with the world. So what we've got lined up for you, first up is some of the font resizing work that Bruno is going to demo for us. Erik did much of the work for it. Then Erik is going to talk in a bit more detail about the sharding project, for want of a better description of it, what's been going on and what to expect over the coming month. We're mindful that it's quite a big project and it's maybe hard to really get a sense of what's going on with it from sort of weekly updates. So Erik's going to talk us through all of that. Then Zoe's going to make her Matrix Live debut and talk about some work she's been doing to make it easier to parse RAID shapes. And then finally, oh, no, we don't. I was about to read a thing off. Oh, yes, we do.
No,
we do, in fact. You're going to do it, aren't you, Matthew? Right, peer-to-peer onboarding. Yeah. Keegan's done a bunch of stuff there just to make it a little bit smoother to get on board on the peer-to-peer project. And Matthew is going to take you through it and show you what's been going on. So, Bruno, are you ready to go?
Yes. Can you hear me?
Very well.
Okay, cool. I hope it stays like that because the call quality has been mixed for me. But let me share my screen. Making sure it's the right one. The right tab. So you should be able to see it now.
Looking good. Bruno the Bloodhound is with us again.
Cool. All right. So here we see the right we all know and love, but on a different URL. It's an ad hoc build. So this is work, as Neil mentioned, has been together a few weeks. And if we go to the settings, two labs. So none of this has landed on develop yet. That's why we're doing the ad hoc build. But here we can enable font scaling. And that will, if we go to appearance, show this in the settings. And why is it not responding?
If it's a live demo.
Yes. It's just slow. My machine is slow. So if I click and wait for a few seconds, then it should grow. I think this is Jitsi maybe. Okay, I tried this before and it worked smoothly. Okay, well, you can see it growing with a bit of lag. And the idea is that most of the elements grow, as you can see, perhaps there's a few things that still just really big. Yeah, the avatars here get a bit clipped, but apart from that, it's fairly good so far. So yeah, kudos again to Erik for putting this together, and for seeing this on develop.
I think one of the other cool things here is that it's factored out enough of the timeline CSS that we can start doing more exciting CSS layouts. At the risk of spoiling everything, I'm cheekily hijack Erik to go and look at a completely different layout of the timeline, and I hear that it's also doing another completely different layout of the timeline too at the same time. Now that we have a bit more flexibility, it's not a stack of cards or house of cards, Venetian blind, CSS, broken cliches. So watch the space for new exotic timeline stuff on the horizon.
Cool. I didn't know that. I'll talk to him now because I would like to see the next layout done in CSS Grid.
Yeah, well, get in there quick because I think he's already looking at it today for the specific variations that we had in mind.
Okay, cool.
I did just want to add as a small footnote that this might, just so everyone knows, this might also impact the default font size because a recurring bit of feedback is that for a lot of people right now the text is just too small. So we'll be dogfooding this on develop first, and then play around with different font sizes, and then pick some sensible defaults and sensible options for people to be able to manage in settings.
Yeah, on the ad hoc build, it's 16 pixels now instead of 15 as what is on develop. So it's already changed.
Cool.
Cool. Well, that's me.
Thank you, Bruno.
All right, is Erik out there? Oh, thank you, Bruno.
I am.
So, Erik, tell us all about it. Remind people why why matrix.org particularly has been slow of late and historically, what the problem is, why we can't just click our fingers and magically fix this, what you've been doing to date, and what people should expect over the coming month, or just a few days, right?
Yeah. So first there was a big bang, and go ahead.
Yeah. So I mean, for those of you that have been looking at watching Matrix Sync, you've been hearing me wittering on a little bit about this every week, and so apparently I'm going to witter on about it some more. But this time I'm going to take a little bit of a step back and explain, I think, from a higher level point of view, because I think we've sort of focused a bit too much on the details of the nitty gritty that I'm doing every day, and sort of try and give everyone a better sense of where we are and why this is hard, and it's not just me slacking off. I've actually made some quick drawings to make this a little bit easier. So I'm just going to share my screen and hopefully, can you see that?
Yes.
Yes.
Beautiful.
Great. Cool.
I love the texturing.
Yeah, it's great. I spent ages making these diagrams, as you can tell. But basically, back in the day, we started out writing a proof of concept called Synapse. It was written in Python, and it was glorious. It was a very simple Python process that just sat there, used SQLite, and it proved the concept. And so we're like, yay. And throughout all of this, we've been saying, hey, we probably should rewrite this so it's not a proof of concept. But like all proof of concepts, obviously it got shipped to production, and 6, 7, however many years later, here it is. But very quickly, we discovered actually some performance problems. The first is database. SQLite is great, but it's also a bit slow when you try and put traffic through it. So we added a database. Woo! That was the first, but not last performance problem, but it was easily fixed. And we continued getting users and continued seeing uptick in traffic. So we started seeing some performance problems in terms of CPU. So we started doing some optimizations, and we started adding some caching, and that was great. And then we added some more features, so we needed to optimize some more and add some more caching, etc., etc., etc. And so this actually scaled for quite a surprisingly long time, just a single Python process sitting there. We occasionally put it on a bigger box, but because it's Python, it only uses one core. Threading on Python is you can't really do effectively. Because of the global interpreter lock. So we started thinking, well, how do we actually scale this up some more? And that's where you start getting into the idea of actually the only way of doing this is to run multiple processes. Now, the problem is, at this point, it's several years down the line. And, we've really kind of assumed that we are a single process writing to a database and we're the only writer. And, we've added caching, and which means that, if we write some data to the database, we need to invalidate some caches. And so it's not quite as simple as just spawning up another Synapse processes and putting it next to it and having a load balancer in front and just round robbing requests everywhere. In particular, it's cache invalidation, which is hard. But the second one is that all of Matrix really is powered by this concept of streams. So when events are coming through, and Synapse comes to persist a new event in the database, a new message in the database, it adds it to the end of a stream. And streams basically allow clients to go, I've gone up to stream position 5. Please, can you give me all events after stream position 5? And then Synapse quite happily comes along and goes, here, have events 6 and 7. So this ends up a data structure looking like that. So you can see we've just written 1, 2, 3, and that's our current position in the stream. Unfortunately, we do some asynchronous writing. So if we can write 6 and 7 before we've finally written 4 and 5. Apparently, I can't actually count here. It was meant to be 1, 2, 3, 4, 5, 6. But anyway.
Well done.
This was done in a bit of a rush. So yeah, this is the second real big problem, because this is all done in memory. All of this stream ID tracking is done in memory on Synapse, and it's actually quite a hard problem to have multiple processes writing to a single stream. It's kind of a big problem in decentralized world, and it's kind of one of the things that, ironically, Matrix solves through the DAG. You can also get off-the-shelf things, but it's hard. It's not simple to solve. Like all great hard problems, I'm going, absolutely not. We're not going to solve that. So we are not going to try and write to the database from multiple processors. We're just going to have a single process writing, but we can move reads off of the main Synapse process. So you end up in a situation that looks a bit like this, where you have a main process that talks to the database, that writes to the database, and you have some workers sitting there that has read-only access to the database. And yeah, you come along and you a request comes in. If it's a get, it goes to the workers, it reads from the database. If it's a write, it goes to the main process and it writes to the database. And that's kind of great because a lot of the API hits are in fact read-only APIs, especially all of the calls from the clients to get updates. The small problem with this is both cache invalidation, and streams, because the workers need to know the current position of the streams because of those asynchronous writes. And obviously, if Synapse writes to the database, the workers need to be told so that they can invalidate all their caching. We could turn off caching entirely, but things really explode in balls of flames if you turn off caching. So it's actually really quite important to keep caching, as it turns out. Annoyingly, caching is the bane of my life when it comes to this sort of thing. So we end up with a really nice kind of world like this. This is the worker mode style stuff. And that's been keeping us ticking over for a couple of years now. We're just slowly moving more and more stuff off of it. But fundamentally, almost all the writes go to Synapse master to be written to the database. And then we stream the writes to the database, the writes to the workers, so the workers know what's been written and they can update their current positions and invalidate their caches. So you can see this on the diagram in that you have this kind of big fat pipe coming from the Synapse big writing process, and it goes down to the workers, and the workers occasionally do some small requests up to Synapse where master when it needs to, but generally big box at the top and just streaming to all the workers at the bottom. So this is actually what it kind of looks like. There's actually a TCP stream per worker, which is kind of annoying. So the more workers you add, actually adds a little bit of load to the master process, which turns out to be annoying if you start to have the worker processes, which is what we're doing today. And so, yeah, like this kind of scales okay until you realize, like we realized today, hey, the writing actually takes quite a lot of CPU. You need to do state resolution. You need to do some auth checks. You need to update all the stuff in the database that requires some calculations and all the rest of it. And that's the problem that we have today, in that all the workers are kind of fine, but this master process is kind of on fire, even though all it's doing is just the writes and hardly any reads. First, hang on. So we kind of really want to figure out a way of kind of splitting the writes up a bit. And actually, the first thing to realize is, hey, we have multiple streams. We don't just have an event stream. We also have a per device message stream and a typing stream, receipt stream, and they're completely orthogonal. They are different streams. They're stored differently in the database. So really, there's no reason why they need to be written on the same worker. The only real reason is because the code kind of assumes it a bit, and all the workers connect to the one process to stream all the updates off of it. So really, all we need to figure out to move some of the writing off to different processes is to fix that kind of replication between workers, so that multiple processes can kind of stream out updates to all the other workers. And then we're done, kind of. So that's quite easy to do. We take an off-the-shelf thing, such as Redis, and go, bam, stick a Redis in the middle. Everything talks to Redis. Everything can write to Redis, and Redis will then fan all of that out to all the other workers. And And yeah, so you just, hey, you want to tell all the other workers that you've invalidated cache, you just write to Redis and it will propagate that around. Great. And that's actually so we've just landed Redis support on develop. So that's very exciting. And that will more and more become the default way of, if you're using worker mode, that will become the way you have to use it in the future. We're deprecating the TCP stuff. But that's a separate point. So kind of, it sounds like, right, that we've almost solved this problem. It turns out that actually, when I said all these streams are orthogonal, turns out that's not quite true. When I came to look at actually how you do this and some of what is involved in the actual splitting this out on a code level, I realized that actually if you write to the event stream, you also need to invalidate some caches. So you write to the cache invalidation stream. And if you write to the typing stream or the receipt stream, you also need to write to the cache invalidation stream. So suddenly we've gone to this really nice world where we can just have orthogonal stream and orthogonal workers. Just suddenly all the streams need to be on one again because they all also write to the cache invalidation stream. And we only know how to have a single writer per stream because it's hard otherwise. And so that's a bit of a sadness. And that's kind of all the work I've been doing recently, is to try and figure out, actually, you have this hard problem of having multiple writers to a stream. How do you solve that? Because there's no actual middle house here. You have to be able to shard streams and have multiple writers before you can move some of these events, the event stream out of the master process or one of the other streams out of the master process. So that's where kind of all of the work has been going, plus a vast quantity of refactoring, annoyingly. But the way that we've done this, and it's kind of, we've got an idea of how to do it now, and we're now implementing it. And the way we've kind of thought about doing this is, this is kind of an example of the stream. Instead of just having stream IDs, we also have, and this is a terrible diagram, by the way, we also have the instant name. So we have instance or process A, process B. So those are processes that are writing the streams. So you end up actually still having a nicely numbered stream here, but you actually have multiple writers. Now, this works if all of the people reading off the stream actually keep track of the position per writer. So you don't have a single position anymore. You kind of have a position of writer A and a position of writer B, and you still need to keep track of the fact that writer A may be slow. So you still kind of have to keep track of them separately, and you might get things out of order. And it turns out I still can't count. Anyway, and so you end up with everything kind of just using, instead of a current position just being a number, you have it as this map. And so that all works really well for cache validation, where you just change all the code base to assume the current position is not an integer, it's a map. And then whenever you kind of come to pull things out of the database or pull things off streams, you use this map position to get all the missing updates. And that will allow us, hopefully, and that's all actually all written on branch, this kind of cache invalidation to stream, so you can write to cache invalidation from multiple workers. And that's great. And so hopefully that now it's just a case of writing the code to move the event stream and all the other streams off of master and have them written on separate processes, which should really, really help. But actually, now that we've done all of this work to figure out multiple writers, we can actually use this to have multiple writers for the event stream and the device stream and all the other streams. So we can then, in the future, further split the event stream writing into multiple processes, and that will let us scale a lot more easily horizontally. The only flaw in that plan is that for things like the event stream, we actually pass these position stuff down to the clients. So we need to figure out how you encode all of the stuff efficiently down to the clients without ending up sending down massive numbers of maps with lots and lots of instances if we turn out to have like 100 instances and stuff. But that's kind of a problem for the future. So yeah, that was a bit of a turbo kind of look through about where we were and where we're going. I hope that gives a little bit of a sense of what's been going on and why it's been hard, and why originally we thought that we could kind of do a little bit of progress, but it turns out that we kind of have to do a lot of work before we can ship anything. But hopefully we're getting to the end of that now.
When did Redis go live?
So I basically, when I fixed some bugs, Halfshot kindly put Redis on his home server. Good news is it worked. Bad news is it started using 100% CPU. So that's a bit of a fail. But I think I know why it's doing that. I think there's some kind of loop in sort of storm of you get a command and then you send one out again and it goes in a big kind of storm. But in terms of getting on matrix.org, fix the bugs. It's a bit late in the day to put it live just as we turn on E2E by default, because that sounds like a terrible, terrible idea. In terms of we're trying to fix some bugs, and changing everything from underneath everyone is unlikely to go well. But hopefully it's just a case of figuring out the best time on deploying it and crossing our fingers and hoping massively.
Cool. Thank you for Turbo Big Bang through to we're starting to see primordial life crawling out of the oceans and climbing the trees. Evolution of Synapse. Thanks, Erik.
Thank you.
Thanks.
Erik, I've been doing a lot of homeschooling with my 4-year-old on
I was about to say the same.
I've got some materials. We can talk about it more offline.
I can happily lend you my 4-year-old as well if you need. Might be at the root of some of our performance problem.
I spent ages trying to find my felt tip pens and I can't find them anywhere. So I was very sad. I was very tempted to get the acrylics out, but I thought that might be a bit much for a Friday afternoon.
You quite like the idea that an entire generation of British school children is going to end up with David Attenborough as a geography teacher and Erik as a decentralized architecture supervisor. Anyway.
All right, folks, sorry we're running over a little bit. Try and get through as quick as we can, but we're coming to the end. We've got 2 more to go, and Zoe is up next.
Hello, can you hear me all right?
We can.
Excellent. Well, I'm Zoe.
Yep.
I'm a developer on the web team, and let me get my screen sharing going. Okay, that's my screen. Can you see this?
Yep.
You should be seeing a view of Riot. Right, great. So every now and then, while using Riot, a user encounters an issue. And we are not Discord, we are not Google, and we don't have a huge amount of monitoring in place to give us all of the juicy details when that happens. We are a privacy-focused piece of software. And that means that when users have an issue, they send us a rage shake instead. So errors don't happen conveniently, so I'm going to use a little tool called the error causer to cause an error happen. And here we go. So as you can see, an error has happened in the client. Now, the problem that we immediately as developers encounter is that our code is minified. And so what we see is not very descriptive. And in fact, what we actually see looks a little bit more like this. It goes to the rage shake output, and then this output goes to our rage shake through it. And the problem we have now is that we might have a descriptive error message like user clicked cause error, but it's not very helpful because we don't really know which file it happened in or which line. So I've made a little tool which just helps us to decode that. It's called the rage shake decoder ring. And this is both a helpful little tool and a data workflow experiment for handling just data fetches. So at this point, I just want to apologize to the design team who have had nothing to do with this. This is just a tool I've thrown together. So if we take that file name, the line number is almost always 1, and the file and the column number, and pop that into here. We've got that file init.js. I've deliberately slowed this down so you can see my progress bars because I'm proud of them. let's see, that's 1275701. And so as that completes, I've got just this currently JSON blob that tells us where that happens, and it's DevTools dialog, line 712, column 34. And if we were to, wrong window switch, if we were to go over to Visual Studio Code and have a look at line 712, column 34, we can see that this is where the error happened. So now we have a little bit more insight into what is going on and where exactly an error happened, rather than it just being something that's completely opaque. Hopefully, when users give us that incredibly valuable information as to something went wrong and they'd like some help with it, we can much more quickly get to where that happened and why that happened. So hopefully this will be useful going forward. And yeah, that's the whole demo.
It's really, really cool. It's a symbolicator, I guess, but for all of our wonderfully minified production bundles. Is the idea to integrate it with RageShake UI at all, rather than it just chucking out random tarballs of logs like it does currently, or is it going to be a separate tool?
You know, I hadn't planned to do that, but that is a fantastic thought. I would like to see more structured logs in future. Myself and Bruno have had some very productive chats about this in terms of just, yeah, we would like to see more structured logs and more tooling to help follow the flow of what's going on with the app more thoroughly. So I would be delighted to work on that.
Yeah,
they put together a tool that just helps to address our most immediate pain.
I'm getting horrible flashbacks to our pre-Matrix days of C++ stripped stat traces that were utterly impenetrable, and having to run them through a symbolicator in order to line them back up with the old symbols to figure out what had actually gone wrong. And everything is new again 15 years later, except now in JavaScript.
Yeah. We have still that on iOS.
Oh, of course, yeah. iOS is still doing it. Oh, well, it's still very cool. Thank you very much. I think that leaves it with me to fill in for Keegan on peer-to-peer stuff.
Yes, please.
Cool. Let me re-share my screen. I have a Virgin Firefox here. And I'm going to go to p2p.riot.im, which is now on, I think, the 4th main generation. And the first thing it does is to kick you out if you've ever used it before. If you and then it magically logs you in. So we no longer have to go through the stupid registration phase. I am now live and on the network. And if I hit the explore button, hopefully, come on, we will see all sorts of random rooms which are out there, including, as always, Brendan's P2P layer. I'm going to join test because I know that there are more people in it. And this is still now talking through WebSockets through to the Rendezvous server. And hopefully we might see backfill. I'm actually cheating slightly by having this open in a Chrome window, except there is still a bug, irritatingly, on the backfill stuff, which means that if the last person spoke is no longer online, it can't backfill. Now, ironically, the reason I'm doing the demo rather than Keegan is that he is currently in the middle of finally fixing that as one of the big restructures, which is really annoying that we don't get the backfill there. It probably will recover. In fact, let me just try refresh. Oh, there it is. Thank God for that. So there is backfill happening there, going all the way through to the beginning of the room. And you can see Neil and Brendan and people. And we've got typing notifications now. Let me go and name myself Matthew Firefox. More people joining all over the shop. How many people have we got on here now? Like 7 or so. So this is very, very usable, but the fun thing is, do we actually know who test is, by the way? They're probably wondering what the hell's going on. They might just be a random. If we go to room settings and look at the room that's been created, we are now on room version 4, so one away from reality and parity with Synapse. I think the only thing that room version 5 brought was better redaction semantics. So if we go and look at these events, like the poor test person saying, what's going on? And look at view source, you can see that we now have nice event IDs, which are hashes of the contents of the message. and it's all working pretty well. We went through a phase where it would occasionally die in the depths of the Go to JavaScript interface, and looking at the console, it is absolutely petrifying, as it still is hammering away on APIs on Dendra that haven't been implemented yet, like all of the encryption ones, for instance. Although we had a slightly interesting realization that in a pure peer-to-peer world, we don't really need end-to-end encryption, because there aren't any long-term places server-side where the history is stacking up. But in practice, of course, people will want it anyway. But yeah, this is basically coming together more and more. Dendrite is having this big brain surgery at the moment to go and refactor how basically the separation of concerns between the Room server and the client API and the Federation API and the Sync API, where I think the idea is basically the Room server ends up storing the DAG representation of the Room, but then the Sync server ends up only ever dealing with a linearized stream version of that. And I believe that the auth logic for going and validating events is being moved around the place too. And actually, Neil, are you out there anywhere?
I am, yes.
Yeah, can you talk more coherently about this than I can, given I've been like read on it for about 10 seconds?
Yeah, so the thing at the moment is that the Room server will just take all of the events and store them. It tries to work out forward extremities, but doesn't work on backward ones. So, or is it the other way around? I can never remember. But anyway, the idea is that the responsibility for actually building the topology will fall in the Room server rather than in the Sync API at the moment, which makes the Sync API much simpler, and it removes all sorts of situations when we're backfilling or we're getting missing events where the Room server will do something, the Sync API has some different topology, and it just sort of collapses at that point.
Cool. Any other news from peer-to-peer stuff before we wrap up?
Invites are half working. As long as you don't try to accept them over Federation, they work beautifully.
Well, almost there.
Yeah, good progress.
Cool. Well, I'm painfully aware that we've run over. Thank you, everybody, for hanging around and your patience. Hope this has been useful. Thanks to Matrix Live watchers for watching along. Hope this was fun to see a whole bunch of random demos from the core team. And I guess I might as well wrap up unless anybody else has anything. Okay. Have a great weekend, everybody.
Thank you. Bye-bye.
Bye. 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 Bye.